All right, folks, so if you remember where we were in this problem, we had just solved for r, and it was this kind of nasty looking, the third root of 24 over pi. So I'm going to go ahead and plug that in up here, the third root of 24 over pi. So it looks like that. So now we're in business here because I have to solve for dr dt, and that's my only variable left. The challenge is going to be actually solving for it because it's going to get pretty ugly. So let's take a look here. First things first, let's square that cube root. So remember, when you square something, a fraction, you square the top, you square the bottom. So this is going to become 1/4 4 pi. Now this is the, oops, let's fix this. This is the third root. And 24 squared is 576, and then this will be pi squared. And then I have my dr dt. Okay, so now I've got this third root that I need to deal with. Now, we can see if we can take a perfect cube out, and I think 576 is divisible by 64. So let's check that here. 576 divided by 64. Yes, it is 9. So 64 is 4 cubed. So that means I can pull out a 4 here. This will be 4 pi. We're going to pull out a 4 in the numerator. Okay, and that is 9. And then we still have the pi squared in the denominator. Just get all the rest of the stuff in here. Okay, so now what? I can divide that 4 pi over. Okay, so this guy right here can be divided over, and I have 1/16 pi. And then I now have this. And I'm going to split this up into 2 cube roots. And if you remember your property of roots, if you take the square root of the whole thing, it's the same as taking the square root of both pieces. In this case, we're talking cube roots. Okay, so I also can get rid of that 4 that's out front by dividing that over. And now I have 1/64 pi, and I have the cube root of 9 and the cube root of pi squared dr dt. Now, you know that I can't leave that cube root in the denominator. You also know that I would be dividing this entire quantity over. All of that is going to be divided over. Okay, so when I do that, that will actually be multiplying by the reciprocal. So I have 1/64 pi. Excuse me, I said dividing by the reciprocal. That'll be multiplying by the reciprocal. So it'll look like this. Okay, and that will be dr dt. Now we got to fix this denominator. This says a third root of 9. Well, 9 is also 3 squared. Okay, now in order to take the cube root of something, there has to be 3 of them down there. For example, 8 is 2 to the third, so the cube root of 8 is 2. 64 is a perfect cube. That is 4 to the third, so the cube root is 4. So if I can make a perfect cube down here, I will be in business. This is the same thing that what you do with rationalizing the denominator. So I have 2 3's down there. I need to get another 3 down there. Okay, so that would look something like that. Notice that whatever I do the top, or the bottom, I have to do the top. So it's like we're multiplying by a version of 1. So now I have that. Okay, the cube root of 27 is 3. Looks like that. So now I can multiply across the top, multiply across the bottom, and I get the cube root of 3 pi squared. If we multiply that, we should get 192 pi. And this is my dr dt. And then my units, if you go all the way back to the original question, we're talking about the radius here. Holy smokes. This will be centimeters per second. And believe it or not, that is finished. Okay. All right, let's do one more and we should be good to go. I have a point that moves around a circle with a radius 9. When the point is at the negative square root of 3, comma, square root of 6, its x-coordinate is increasing at the rate of 20 units per second. So that tells me right there, dx dt is 20 units per second. Okay. I also know that my x is this and my y is that from the point given. Okay. It says how fast is the y-coordinate changing. So I am trying to find dy dt. I don't know it. Okay. The other thing that you need to be aware of is they tell me this is a circle with a radius of 9. Okay, so that is going to help me get my equation. Equations of circles, you should remember or should know x squared plus y squared is r squared. Well, I know the radius, and that radius is not changing. Okay, my radius is 9, so this will be an 81 over here. And now I should be ready to differentiate. This is kind of similar to those couple of those homework questions you had. Hold on a second. This should be dx dt. A couple of those homework questions from your book that we talked about. How you're given the equation, except for this time you had to come up with your own equation. Remember, these 2's are irrelevant. My x, got that. My y. And I'm ready to solve. Actually, we can go ahead and add that over to the other side so we can start solving here. Should look something like that. Now we'll divide by that. And we're just going to rationalize this. Should look like that. Oh, let's see here. Oh, did I put them in the wrong spot? Something's not right here, kiddos. I have my answer should be 10 radical 2. So, oh my goodness. Oh no, that's still okay. Oh my gosh. Hopefully you caught me on this one, guys. I put my x and my y coordinates in the wrong spot. Well, let's backtrack here. If you go up to this step, I was supposed to be plugging in x is negative radical 3. Right here. And y is supposed to be radical 6. Okay, so now let's move these guys around. Looks like that. We'll divide by the radical 6 and we'll rationalize. So I now have 20 radical 18 over 6. But radical 18 can be broken down. We can take out a 9, which really comes out as a 3. So 3 times 20 is 60. And I'll have a 2 left in there. And now I get my 10 radical 2 for my answer. Okay, so those were the last two questions I wanted to do with you today. And then there's your homework assignment. Hope you guys have a great weekend, and I will see you on Monday.